So let's look here at what we've got. All right, we'll pick a rational function here. So let's say we want to graph yet another rational function, and we'll look at 3x squared over x squared minus 4. Alright, so we'll go through the same steps we've been going through here. We'll identify that domain first. So, Emma, can we, or do we have any domain restrictions here? Can we potentially, like, divide by 0, for example?
Yes.
Yes. Okay, so for what values here will we be dividing by 0? Okay, yeah. Okay. Yep. So 2 and negative 2 would be our 2 zeros there. And so then what would our domain interval look like, or how would you describe that interval for the domain? Okay. Great. Very good. Exactly. Okay, so there's our domain. Alright, bless you. Alright, and let's take a look at our vertical asymptotes then. Okay, vertical asymptotes here. Let's see here. Colin, do we have any vertical asymptotes here? So, vertical asymptotes occur when the function is undefined. So for what values of x here are we going to result in our function being undefined, or dividing by 0? Yeah, and? So x equals 2 is one of them. What other value, when you plug it in for x there, will give you 0 in the denominator? And here we just found when the domain was 0, or when that x squared minus 4 equals 0, it's when x is positive 2, but also when x is what?
Negative.
Yeah, negative 2, right? Right, okay. Good morning. So it just so happens, right, Colin, that those domain restrictions, either the domain restriction, in cases of rational functions, it's going to turn out that either those domain restrictions are going to result in vertical asymptotes or a hole. One of those two. Okay, so that's what we can use those two. Okay, in this case, both 2 and negative 2 are vertical asymptotes, because when you plug either one of those in, you don't get 0 over 0, right? A 0 over 0 indicates a hole. You get a number that's not 0 over 0, okay? So both those cases, we get that. All right, and so then, for holes, there's not going to be any then, right? There won't be any, because we have no other domain restrictions to worry about here. There will be no holes. Okay, there's no number that when you plug it in for x, you'll get 0 over 0. Okay. So let's go to the next thing here. Zeros. Okay, zeros. So Devin, do we have any zeros here? Yes. Yeah, 0, 0, right. So x equals 0. Because the numerator equals 0 there. I guess I can put like 3x squared equals 0 and then just say, okay, well, x is going to be 0. And so then, yeah, if we plug that 0 back in, it'll be 0, 0. So now number 2, I guess let me back up just a slight bit here. Number 2, we have 2 vertical asymptotes. So that's a bit of a unique situation from, prior problems that we've done, having 2 vertical asymptotes. So we could result in a different looking graph than we normally have seen, right? But anyway, we'll kind of continue and see what happens. All right, horizontal asymptote. Okay, let's see here. So, Sabrina, how do we find the horizontal asymptotes of a function? What do we do? Okay, right. So yeah, we're going to take the limit as x approaches infinity of this function, and in this case, you're exactly right. It's going to be the ratio of the coefficient. So that'll be what then? 3 over 1, or just 3 is fine. And so that means the equation for our horizontal line, or horizontal asymptote, will be y equals 3. Very good there. Well done. Okay, so now we've got some information. Again, I'll leave some space for like additional points if necessary here. Okay, and then we can just go about graphing this thing. So let's see. And again, these steps that we just did here, we can do those steps in any order, right? It's not like you have to do the domain first, right? And then you have to find the vertical asymptote or holes, and then the zeros. You can do these steps in any order you want, but you do want to find, you know, all this piece. You want to be able to find all these pieces of information. Okay, so that's why we do that. Okay, and I just keep it in the same order because why mix it up, right? Okay, so let's see here. I have a horizontal asymptote at 3, so I definitely need to go up to there. So 1, 2, 3. Again, we want to plot those asymptotes in first. They kind of create a frame, or you know, like the bones of our function. Give us a good idea of at least some boundaries and behaviors that the curves will follow. Yes. Oh, it's off the screen. Sorry, I'm just putting tick marks down. Thank you, though. Okay. So, vertical asymptotes at 2 and -2. So, let's see, here's my vertical asymptote at 2. And at -2. It's not necessary to like label those if you don't want to. I just label them out of habit. You don't have to label them. Okay. Same thing with the horizontal asymptote here. Okay. So instead of a single vertical asymptote that kind of splits our graph into a left and a right-hand side, we have 2 vertical asymptotes, which kind of gives us a left-hand side, a right-hand side, and like a middle piece. And so we have to figure out what this thing is going to look like. Okay. So let's see. We do have 1 point to plot, right? We do know that we have a 0 at 0, 0. So we can put a big old point at 0, 0. And so now to try and figure out what this graph is going to look like, we need to come up with some more points here. Okay? So, you know, let's maybe try and figure out this middle piece right here first. Okay? What's between the 2 vertical asymptotes here. So maybe plugging in like 1 and -1 would be a good idea. So let's try that here. So let's see. If I do f of 1, we'll get 3 over 1 minus 4, so 3 over -3, so -1. And if I plug in f of -1, well, we'll get -1 squared, which will still be 3 on top. It'll still be -1 squared, so it'll be 1 minus 4, so it'll also be 3 over -3 or -1. So we have the point 1, -1, and -1, -1 on our graph. So I think it's safe to say that we can probably just go ahead and say it's going to do something like this. All right, almost like a little parabola looking thing there. Interesting. Still needs to have some more graph, though. It looks like there could be still some more over here on this right-hand side, and some more over here on this left-hand side. So we'll just, again, pick an x value. I'll pick the x value over here on the right-hand side. I'll do like 3, right? 1, 2, 3. I'll just go one more over from that vertical asymptote. Again, you can pick whatever x value you want over here to kind of get an idea, but, you know, 3 is there, so why not? So let's see here. So f of 3, it'll be 3 times 3 squared over 3 squared minus 4, so let's see, that'll be 27 on top, and 3 squared is 9 minus 4 is 5. Oh man, fractions. okay. We can do this. All right, we can do this. 27 fifths. All right. Well, 27 fifths. That's 5 and 2 fifths, or in other words, 5.4. Right? 5 goes into 27 5 times. So there's a whole number of 5, and then there's 2 fifths remainder. 2 remainder, so 2 fifths left over. So 5 and 2 fifths. So let's see here. We'll go to 3 and we'll go up to 5. So 1, 2, 3, 4, 5, and just a little bit more. And there's our point. And if you want, you can get more points from this point, but once we kind of see that this point is in that kind of little sector, then we can guess that it's probably going to graph something like this, and in fact it does. Okay, just like that. And we'll do something similar over here for the left-hand side, right? We might think, okay, well maybe because of maybe it's got some sort of symmetry here. Maybe it'll go down here, but maybe it's the symmetry about the x-axis, so maybe it'll go, or sorry, about the y-axis, right? Symmetry about the y-axis, so maybe it's going to go up here. So again, we'll pick a number. Let's try -3, for example. Well, since we're going to be squaring those x values, it's going to end up being the exact same thing as we got before, the 27 fifths. And so we can plot that point here at -3, and then 3, 4, 5, and a little bit more. Okay, something like that, and you can go like that. Okay, and so there's our graph. Weirder than typical stuff we saw yesterday, and we can also check that on our graphing calculator just to make sure we're not way off base. Okay, and sure enough, there it is. Okay, you can even draw in your horizontal asymptote if you want to at 3, right, just to see that borderline. It's kind of interesting, the quadratic piece, that middle piece doesn't go up and you have the horizontal asymptote as a border either. It's a little bit spaced down from it. But there we go. Questions on any of that? Alright, so today you're going to see some weirder rational functions than what we saw yesterday. Okay. Before we dive right into graphing with a slant asymptote, I want to kind of go over what a slant asymptote is. Have you guys heard of slant asymptotes before? Yes, okay, so this is review, right? Okay, do you guys remember, how do you know if a graph has a slant asymptote or not? How can we tell by looking at the degrees? It has to do with the degrees. Oh, okay, well then that's good that we're reviewing here. Or maybe some of you remember it, but you're not sure, so you don't want to quite say it, because know that I'll belittle you in front of the entire class. Just kidding, I would never do that. Okay. Slant asymptotes. Oops, asymptotes. They occur when the degree of the numerator is 1 greater than the denominator's degree. Exactly 1 greater. Okay, so if your denominator has a degree of 2, your numerator has to have a degree of 3 in order to have a slant asymptote. Okay. Alright. So let's jump. We'll just do, well, okay. We'll kind of just jump into an example of just finding a slant asymptote, and then we'll do a problem with a slant asymptote in it. So, ID, the slant asymptote, for each function. Okay. So it's all well and good to know when a function has, or when a rational function has a slant asymptote, right? You can identify it. But then coming up with the equation for an asymptote is a little bit trickier, right? A horizontal asymptote is easy. You take the limit as x approaches infinity, and then just whatever number you get there, that's your horizontal line. But to come up with the equation for a slant asymptote, we need to kind of have a y-intercept and a slope, right? Because it's a slant asymptote, so it's like the equation of the asymptote will be a line, and a diagonal line, right? Not a horizontal line. So the way we identify what a slant asymptote is you actually just do the division. Okay, so for example here, let's say we have our function is x squared plus 1 over x minus 1. So first of all, it's important to realize, right, that this function would have a slant asymptote because the degree on top is 2, the degree on the bottom is 1, and so the numerator's degree is 1, exactly 1 more than the degree on the bottom. Okay. So let's actually do this division. And you can divide this, actually, how should we go about dividing this thing? What should we use? Yeah, Henry? Synthetic division would work, absolutely. If you wanted to, you could also use long division, right? Either one. So let's use synthetic division. All right, let's see here. So, ooh, gosh, that was last unit, Mr. Widmeyer. I forget. What goes in that box there? 1. Right, okay. What goes in the box is the 0. So if x minus 1, the factor there, and 1 goes in the box. All right, great. That was easy. Good job. All right, so then we just put a 1 there for the 1x squared, and then a 1 there for the 1, right? What? Oh, the placeholder. Gosh, that was last unit. I forgot all about that stuff. Yeah, we put a 0 in there for the placeholder, right? It's x squared, 0x, and then 1. All right, so we'll drop the 1 down. 1 times 1 is 1. 1 plus 0 is 1. 1 times 1 is 1. 1 plus 1 is 2. Okay, it doesn't divide evenly. That's okay. When it comes to finding the slant asymptote equation, we don't really care whether there's a remainder or not. In fact, we just throw out the remainder, all right? And the equation of the slant asymptote is going to be y equals x plus 1. It's just what does evenly divide out there. So in this case, x plus 1. That is your equation for your slant asymptote. Okay? That's it. You throw out the remainder, it's just y equals x plus 1. Okay? All right, so here I'll have you guys try one then. Okay, so find the slant asymptote for this one. F of x equals 2x squared minus 5x plus 7 divided by x minus 2. Okay, so go ahead, take 30 seconds. Figure that out. Okay, Jackson, what did you do here? Synthetic division, okay, so what did you put in the little box? A 2, and then your coefficients were what here? Okay, so we'll just drop the 2, 4, negative 5 and 4 is negative 1, negative 2, and 5. Okay, so then, what is the equation for our slant asymptote? Y equals 2x minus 1, exactly right. Okay. Questions on any of that? Okay. Alright, so let's do a rational function with a slant asymptote. And this is our last problem we're going to do today. Okay, so we're we're going to have lots of time for homework. All right, pretty chill Friday, hopefully. Do we have a lot of homework? Define a lot. More than 6?
We've had 3 problems with any homework.
True. I'm giving you 5. Okay. All right. 5 for homework. But of course, you're going to have so much time in class, you'll probably have no homework. So.
How many do we have? Oh,
I would have dropped a bunch of times.
No, she has her own shower in Mr. Raw's office. Did you miss that conversation?
Yeah, the phys ed teachers have their own showers in their offices. Yeah.
4:45.
Yeah. Because it's not appropriate for the phys ed teachers to shower. I guess in the kids' ones maybe.
She's like, yeah, I showered here. I was like, in the locker room.
Mm. Coach Stein does too. He works out in the morning and he'll go shower in his, the male one. All right. All right. So let's go through this same idea. All right. The domain. All right. So Luke, domain restrictions here. X equals 1, right? So then our domain interval negative infinity to 1, bless you, union 1 to infinity. Okay. Let's see here. So something we haven't heard from. Let's go. All right. So then, Robert, what about? Do we have any vertical asymptotes then? As a result of that, I mean, is that one? Is that going to be a vertical asymptote or is it going to be a hole? Which one is it? A hole? So how did you determine it's going to be a hole? Does the top pack?
No, it doesn't.
Yeah.
It would just be a first class.
Yep, it's going to be a vertical asymptote. Exactly right. Yep. And again, what the way we determine, folks, those domain restrictions, right? In this case, 1, right? We want to exclude 1 from the domain because it would make us divide by 0 here. And the 1, though, if you plug that 1 into the function, it does not give us 0 over 0, right? It would give us 1 over 0. If you actually simplify the numerator and simplify the denominator, it would be 1 over 0, which indicates then a vertical asymptote. Holes are indicated by the 0 over 0 when you plug it in. So there are none. No holes. Okay? All right, so let's see here. So zeros, let's see, this keeps repeating. Megan, zeros. How do we find if there's any zeros in this thing? What do we want to set equal to 0 here? The top, the numerator. So x squared minus x plus 1 equals 0. So Robert already kind of told us, right, that this thing doesn't factor.
Yeah.
So it doesn't factor, so that means we just give up? No. No. What should we try? Right, I know, just give up. I'm done. Take the L, right? I know things. Anyway, no, what should we really do here?
I don't know.
Some people just roll their eyes way too much there. Alright, sorry. Yeah, we can try the quadratic formula. Let's see here. So negative 1 plus or minus the square root of b squared minus 4 times a times... Oh. What's going to happen? Yeah, it's not going to be real, right? Because we have a square root of negative number in there. Alright, so we now can give up, okay? Because we keep it real in this class. Alright. So now look for... So a step 5 now, right? When we go to evaluate the horizontal asymptote is when I also like to evaluate the slant asymptote. Again, this is my organization. You do not need to follow this order whatsoever, okay? But I just find that it's helpful to have some sort of process or something. I don't know, maybe. You can do whatever you want. But in step 5 here, here's the catch, right? So we want to identify whether we have a horizontal asymptote and or a slant asymptote. So first of all, a horizontal asymptote occurs when we take the limit as x approaches infinity, right? Of our function. But if we take the limit as x approaches infinity of our function, what is this going to approach? Does not exist. Infinity, right? So therefore it does not exist. The degree on top is bigger than the degree on the bottom, right? That's that one, scenario where if the numerator's degree is bigger than the denominator's degree, as x approaches infinity, this thing's going to get way out of control. It's going to get bigger and bigger and bigger and go to infinity, so it does not exist. All right. So then my question to you is, if a graph has a horizontal asymptote, will it also have a slant asymptote? Okay, we can think about that.
Wait, question.
Yep.
If it doesn't exist, but you have a slant asymptote, can it be both? Because
So-
the horizontal asymptote, is there, but it doesn't exist. Like, it's still horizontal.
Does that make sense, though?
Yes.
To say that it's there, but it also does not exist? Like it's imaginary?
You could have both at the same time.
Right.
So yes. Because
You
do have one.
you want to
just
consider,
not there.
but okay, fair enough, but on the graph, I'm not even sure if I can, argue that at all, but what I can say is, on your graph, will there be graphs that have both a horizontal asymptote graphed and a slant asymptote graphed? No, they are mutually exclusive, okay? Just like your domain restrictions will either be, in these cases, will either be a vertical asymptote or a hole, okay? When it comes to horizontal asymptote and slant asymptote, you will have one or the other, but not both, okay? It's impossible to have both. The nature of a slant asymptote requires that your degree on top is bigger than the degree on the bottom. If that's true, then a horizontal asymptote can't exist because the degree on top is bigger than the degree on the bottom, and so it's going to go to infinity, right? Likewise, the other way around, for a horizontal asymptote to exist, there's 2 of the 3 scenarios where a horizontal asymptote exists. Either the degree on top is the same as the degree on the bottom, or the degree on the bottom is bigger than the degree on the top, which would then indicate there's no slant asymptote, okay? So, you will never have both a horizontal asymptote and a slant asymptote graphed at the same time. So let's do this division here. I'll use synthetic division again. Okay. And so let's see, we'll drop the 1 down, 1, negative 1 and 1, 0, 0 and 1 is 0, and then 1. Okay, again, throw out your remainder. And so the equation of that slant asymptote is just y equals 1x, or just x, if you want. There, it's fine. It's y equals 1x, or just x. That's the slant asymptote. Okay. So, we'll hold off on doing additional points unless we need them here. I'll just go right into the graph. All right, so... question?
Is the slant asymptote always going to be like a linear function?
Yes. So, yep, exactly right, a line. Yeah. Slant asymptote will always be a line. There are other, I guess, quadratic asymptotes and stuff like that, but we're not going to worry about those, because, I guess at some point we have to stop and just say, all right, enough asymptotes, let's just move on, right, kind of thing. But slant asymptotes we do want to cover. Alright. Okay. So again, just like when you have, an equation with no slant asymptotes, okay, with just like a horizontal asymptote or something, you want to put those asymptotes in first. They're like the bones of our function, right? So we'll put those in. Okay, vertical asymptote of x equals 1. and then the slant asymptote of y equals x. So we're going to graph the line y equals x. So that line, y equals x, right, has a slope of 1, or 1 over 1 as a fraction, right? And a y-intercept of, what's the y-intercept of this? 0, right? It's plus 0. Okay? So we're going to be at the y-axis, or sorry, at the origin there, and we'll just go up 1, right 1. Okay, and I'll try and like graph this. Relatively accurately here. Okay? And so there's our slant asymptote. Okay. Okay. So we have no zeros. No zeros. This thing never crosses the x-axis. Okay. So we have no points to put down right now. Okay, nothing. So we gotta figure out some points. So let's do an easy one. Let's maybe find like the y-intercept, right? Because the y-axis is pretty easy to work with. So let's find like f of 0. Okay. So we plug in 0 here, and we're gonna get 1 over negative 1, which is negative 1. So we get the point 0, negative 1. Okay. Again, if you want to get more points at this point, you can, but you know, with that 1 point, we really kind of have enough information here. We just follow the asymptotes. Okay, and there's what our graph is going to look like, something like that. And so you may guess, you may be tempted to guess that, okay, you know, it's just going to probably be up here in this corner. And you're right, but it's not always going to be that case. There are situations where it could be, you know, these two, like the bottom 2 parts, or, you know, the top 2 parts and stuff. So you do want to check one more point here, so let's just try 2, because again, 2 is here. 1 over there, so f of 2. And so let's see, f of 2 is going to be 4 minus 2 plus 1 over 2 minus 1, so 3 over 1. So 3? 2, 3. And so, yes, if you guessed it would be up here, then you were right. And so there's the graph. Kind of interesting stuff. And if I show you here real quick on the graphing calculator, x squared minus x plus 1. Okay, and there it is. Right? And again, the nice thing is with that slant asymptote, you can put in the slant asymptote equation, y equals x. Alright, if you wanted to, you can be even like, I don't know if you guys do this, you can change the kind of line that draws. So if you hit enter, that draws a thicker line. If you hit enter again, that'll shade above and shade below for inequalities. There's the dotted line option. Oh, and it doesn't do dotted line. Great. But it should. It's supposed to draw a dotted line there. So I guess, who knows why it didn't do that. But there it is. So there's just an asymptote. Okay? So, questions on any of that? All good? Alright, so let me get you guys your 5 problems then for homework. Okay? Have you started on that?
Yeah. JK.
Page 191 again.
Yeah. I literally just did mine.
Okay.
You guys want to each other?
Oh, nice. So, the first four are graphs. Number 90, it's kind of going backwards. You'll be given some information, and then you'll be asked to come up with a rational function that has those characteristics. So it's kind of fun. It's a capstone. All right, so let's get to work on those.
Exactly.
What's that?
7%.
Yeah. I was gonna say, are you feeling it now? Now it's just carved up. Oh my gosh, I'm sorry. Yes. Let me stop the video here. Oh.